Hello everyone. Today we are going to look at transformations of sine and cosine functions. Previously, you learned how to sketch y equals sine theta and y equals cos theta. Sine theta and cos theta are periodic functions because the curves keep repeating themselves. The period of sine cos theta is 360 degrees because the curve repeats itself every 360 degrees. And let's remember the definition of period. It is the horizontal distance for one full cycle. The amplitude of sine theta is 1 and the amplitude is halfway of the vertical distance from the maximum to minimum of the curve. And amplitude is always positive. So for sine or cosine, maximum value is 1, minimum value is -1. So the vertical distance from maximum to minimum is 2 units. Half of it would give you 1 unit. So amplitude is 1 unit for sine function or cosine function. So the transformations on sine function can be represented as a times sine k times theta minus d plus c, and same thing with the cosine function. So you already know what a, k, d, and c represents because we worked with transformations of other types of functions such as transformations of exponential functions or transformations of square root functions. So let's go over again those values. So A represents vertical stretch and compress. If it is negative, it also represents reflection in x-axis. Okay, so if we have y equals sine theta using the key points, we can sketch it. We have 0, then we go to the maximum, then 0, then minimum, and a 0 again. And those key points, let's remember, happens every 90 degrees. So if we have y equals negative sine theta, so there's a reflection in x-axis. So we again start from a 0, but then when there's a reflection, instead of going to a maximum, we will go to the minimum. So minimum, 0, maximum, and 0. So that would be one full period for negative sine theta. And again, those key points happening every 90 degrees. So if we have y equals cos theta, again using the key points, we can sketch it, and we start from a maximum, so which is 1, y value is 1, and then we go to the 0, go to the minimum, go to the 0, and go to the maximum. Again, those key points are happening every 90 degrees. So if we have y equals negative cos theta, then there is a reflection in x-axis. Then instead of starting from a maximum, we will start from a minimum, go to the 0, go to the maximum, go to the 0, and go to the minimum again. So that would be negative cos theta. And again, so the maximum values are 1 and minimum values are -1. Okay, so if we take the absolute value of the a value, that will give us the amplitude of the function. Okay, so k value represents horizontal stretch and compress. If it is negative, there is a reflection in y-axis. So when there is we said that this period for sine theta or cos theta is 360 degrees. If there is a horizontal stretch, then that period will be bigger. When there is a horizontal compress, then the period for that function will be smaller. So how can we calculate the period using k? Here's the formula. Period equals 360 degree divided by k. D represents the horizontal shift. So for trigonometric functions, we will call horizontal shift a phase shift. So if D value is positive, then there is a phase shift to the right. If D value is negative, then there's a phase shift to the left. Let's say if you have y equals sine theta minus 30 degree, then there is a phase shift 30 degree to the right. If you have y equals, let's say, cosine theta plus 50 degree, then there is a phase shift 50 degrees to the left. So C value is the vertical shift, and that will give us the equation of the axis. So y equals C. So that axis is the line that is going in the middle if you look at maximum and minimum. If there is no vertical shift, the equation of axis is y equals 0. But if there is a vertical shift, that line where the zeros are located will move up or down. These functions can be sketched by finding amplitude, period, the locations of key points. So those key points are happening every quarter period, because we said that these key points are happening every 90 degree, and one period is 360 degree. So 90 degree is 1/4 of 360 degree. So key points are happening every quarter period. We can also find phase shift and the template and the equation of axis to sketch. Okay, so what is the template? Template are the units on the x-axis. This is how we are going to scale our x-axis. So here are the steps when sketching transformations of sine and cosine functions. First, we are going to scale our x-axis using the template. Second, put the maximum and minimum y values on the y-axis. Third, draw the axis using a dashed line, which is y equals c. Then mark the start point using the phase shift and other significant points using quarter periods. Finally, draw a smooth curve using these significant points or key points. So template can be calculated by taking the greatest common factor between quarter periods and the phase shift. So let's look at some examples. Example 1. So we are going to sketch f of theta equals 3 sine theta. So we are going to look at all those important information to sketch that graph. So what is the amplitude? We said that is the absolute value of the A. So here A is 3, so absolute value of 3 is still 3. So period. So again, only the k value affects the period. So if there is no k value, means that it is 1, means the period is still 360. In this case, k is 1, we don't see anything, so k is 1, so the period is still 360 degrees. So zeros, max, and mins, so those are the key points. So they happen every quarter period. So if one period is 360 degrees, then divided by 4, you get 90 degrees. So key points are happening every 90 degrees. Phase shift. So phase shift, we need to check the D value. So in this case, we don't see any D value, so there is no phase shift. None. So template. We said that template is the greatest common factor between quarter periods and the phase shift. Since there is no phase shift, we can just use the quarter periods for the template, so which is 90 degrees. Equation of axis is y equals c value. But in this case, we don't see any c, means that c is 0. So y equals 0 is the equation of axis. So again, we can follow these steps to sketch it. Okay. So first, we are going to scale the x-axis. we said that we are going to use a template to do that. In this case, we can use 90 degree. Okay, so 90 degree, 180, 270, 360, and actually I'm going to show you how it looks like on the negative side as well. So negative 90, negative 180, negative 270, and negative 360 degree. Then second, put in the maximum and minimum y values on y-axis. So in general, maximum value can be calculated as the equation of the axis plus the amplitude. So in this case, equation of axis is 0 and amplitude is 3. So maximum value is going to be 3. And minimum in general can be calculated as equation of axis minus the amplitude. So 0 minus 3 gives us negative 3. So that is the minimum value. So let's mark those, 3 and negative 3. Third step, draw the axis using the dashed line, which is y equals c. In this case, c is 0. So again, so equation of axis is y equals 0. So that is exactly the x-axis. Okay, next step, mark the start point using the phase shift. Well, in this case, there is no phase shift. So then we don't have to apply the phase shift. It is a sine graph, and we said that for sine graph, these are the key points. So it starts from a 0, go to max, 0, go to min, and 0. So we will start from a 0, and we will go quarter period horizontally and mark the maximum, quarter period horizontally, mark the 0, another quarter period horizontally, mark the minimum, and quarter period horizontally, 90 degree horizontally, and we mark the 0. So if you draw a smooth curve using these key points, that's what we're going to get. And of course, this goes positive infinity on the right side. I'm just going to show it with an arrow here. So if you apply the same pattern on the left side, so we need to go to the minimum here, and after 90 degree we go to the 0, 90 degree horizontally we go to the maximum and go to the 0. Again, on the left side, this graph again go to the negative infinity. We can just show it with an arrow. Let's look at the second example. Graph f of theta equals 3 cos theta plus 2 on the following grid provided, but actually grid is not provided, so you can just draw your own x and y axis. Okay, so again, amplitude is the absolute value of a. A is 3, so amplitude is 3. Period is 3. We can calculate it as 360 divided by k. In this case, we don't see any k. K is the number in front of theta, which we don't see, so it means 1. So then the period is 360 divided by 1. It is still 360 degree. Zeros, max, min. So these are the key points. Again, we need to calculate the quarter period. So one period is 360 divided by 4. You get 90. So those key points are happening every 90 degree. Phase shift. So if we had a bracket here and a number beside, then we could see the phase shift. But in this case, we don't see anything. It means that it is 0. So phase shift is 0 or none. Template is the greatest common factor between quarter periods and phase shift. In this case, again, there is no phase shift. Then we can just use the quarter periods as template, 90 degree. Equation of axis. So in this case, we see that c value is 2. Then equation of axis is y equals 2. Okay, so if we follow the steps, first scale your x-axis. So we go by 90 degrees in this case. So 90, 180, 270, 360. On the negative side, negative 90, negative 180, negative 270, negative 360 degree. Step 2. So we put maximum and minimum value. So again, maximum is, we said equation of axis plus the amplitude. 2 plus 3 gives us 5. Calculate the minimum, equation of axis minus the amplitude. 2 minus 3 gives us negative 1. So we are going to mark negative 1 and 5. Step 3. So we are going to draw the axis, okay? And equation of axis is y equals 2. So draw a dashed line for the axis. That is y equals 2. Next step, mark the start point using the phase shift. In this case, there is no phase shift. So this is a cosine graph. And we said that for cosine, we start from maximum, go to 0, then minimum, 0, and maximum. So that is the pattern. So looks like we have to start from the maximum since there is no phase shift. So we can just put our maximum on the y-axis. And then we check the quarter periods. So it's 90 degree. So we go 90 degree horizontally, put the next 0. But remember, so if there is a vertical shift, now we have a new axis. So zeros are not going to be on the x-axis, but the new axis that you draw. Okay, so we go to the 0, then the pattern says go to the minimum. So we go 90 degree horizontally and go to the minimum. 90 degree horizontally, go to the 0. And again, we go 90 degree horizontally or quarter period and mark the next maximum. So draw a smooth curve using those key points. Again, this graph goes to infinity on the right, so I'm just going to put an arrow at the end. So we are going to repeat the same pattern on the left side. So I need to go quarter period horizontally, draw the put the next key point. Again, 90 degree, go to the minimum. 90 degree, go to the 0. 90 degree horizontally and go to the maximum. Again, this graph goes to negative infinity on the left. I'm just going to put an arrow at the end. Let's look at example 3. That is graph f of theta equals negative 2 sine theta plus 1. So amplitude, absolute value of A. So absolute value of negative 2 is positive 2. And again, amplitude is always positive. Period, 360 divided by k value. So in this case, k value is 1. So there is no change in period. So period is still 360 degree. So zeros, max, and mins, these are the key points. So we need to calculate the quarter period. So period is 360 divided by 4, you get 90 degree. So key points are happening every 90 degree. Phase shift, we don't see phase shift, so none. Template, greatest common factor between quarter periods and the phase shift. So in this case, there is no phase shift. Again, we can use the quarter periods as template. Finally, equation of axis. So C value is 1. So y equals 1 is the equation of axis. So let's calculate the maximum and minimum. Maximum, equation of axis plus the amplitude, 3. Minimum, equation of axis minus the amplitude, negative 1. Okay, so again, let's follow the steps. First, scale your x-axis using the template. So for our template, we are going to use 90 degree. 90, 180, 270, 360. On the negative side, negative 90, negative 180, negative 270, negative 360 degree. Mark minimum and maximum on y-axis. So minimum is negative 1 and maximum is 3. So then draw the axis. So axis is y equals 1. So draw the axis y equals 1. Next step, mark your start point. If there's a phase shift, of course, you have to look at the phase shift. But in this case, there is no phase shift. So then we can just look at the pattern for sine theta. If it was, if a value was positive, then the pattern would be 0 max, 0 min, 0. If the a value is negative, then the pattern is 0 min, 0 max, 0. Okay, so it is negative sign. Then we start from the 0, so which is going to be on the new axis that we draw. Okay, so we go quarter period horizontally, which is 90 degree, and mark the minimum because it is negative sign. So we don't go to maximum, but we go to minimum. So we go again quarter period horizontally, mark the 0, another quarter period 90 degree, we mark the maximum, and then go 90 degree to the right and mark the 0. Draw a smooth curve using those key points. Again, x is going positive infinity on the right. I'm going to show it with an arrow. On the left side, repeat the same pattern. So go to 90 degree, mark your max, 90 degree, 0, and you go another 90 degree to the left, mark your minimum, and another 90 degree, mark your 0. Okay, and again, pay attention. The zeros are not on the x-axis, but on the new axis that you draw.